Today this video is going to take you through some Earth geometry, and in particular how to find distances on the Earth. Now, before we start actually calculating distances, what you need to remember is the difference between the longitudes and the latitudes. So remember that your lines of longitude run from the North Pole down to the South Pole. They're all called great circles, and the 0-degree longitude is called the prime meridian. So another name for the longitudes is meridians, but they're all basically the same size, and they run from 0 degrees. We can go round to 180 degrees east, and we can go to 180 degrees west, and that would join together on the opposite side of the Earth to where you see the prime meridian marked there. Now, our parallels of latitude, on the other hand, are all different sizes. The only one that's the same size as a longitude is the equator, and that's the 0-degree latitude here. So all of our parallels of latitude get smaller and smaller as we head towards the poles. So we can basically go from 0 degrees from the equator, we can go up to a maximum of 90 degrees north, that would be the North Pole, or we could go down to a maximum of 90 degrees south, and that would be the South Pole. Now, when you're calculating the distance, we need to work out which of these types we're traveling along. So if we're traveling along a longitude, so heading like in a north-south direction like that, then we need to use this formula here that's on the QCAA formula sheet. Because all the longitudes are the same, it doesn't matter which one you're on, you would calculate the distance the same way. On the other hand, if you're traveling along a latitude, like in this direction, so you're sort of traveling from east to west or vice versa, it depends which one you're on. So our rule needs to take into account of which latitude we're on. So we're using this rule here. And the cos theta, that's where we're taking into account the latitude that we're on. Now I'm going to take you through a couple of examples just to show you what I mean. So example 1 here, I've got 2 places that we're traveling between. Now notice every time you get asked one of these questions, when you have the 2 places, something is going to stay the same. In this case, they're both 150 degrees east. Now the first thing I like to do is just draw a diagram to sort of visualize where I'm traveling. Now here's a bit of an Earth drawing. So I'm going to put in my 0 degrees, the equator, latitude, and my 0-degree longitude, the prime meridian. And then I'm going to mark these 2 places. So firstly, we've got 70 degrees north. So obviously that's above the equator. Let's just say it's somewhere up here. And 150 degrees east. So if we're east, we're to the right of the prime meridian. So I'll just do it this way and indicate that that's 150 degrees east. Now the other, so this where they're intersecting, that's the location of this place here. The second location is 30 degrees north. So that's not quite as far north as 70 degrees, but it's still above the equator, so I'll just pop it down there, 30 degrees north. So here now we can see now that to travel between these 2 places, we're traveling on a longitude. So we're going to be using our basic rule that distance is equal to 111.2 times the angular distance. Now the angular distance, we have to be careful calculating that. We'll need to work that out first. You have to consider whether you're crossing over the equator or not. So here, both our locations are in the north. So when they're both the same, we're going to subtract our angle. So it's going to get the angular distance. So it's 70 degrees minus 30 degrees, which is 40 degrees. And that's what is going to go into our formula to calculate the distance. We can say, therefore, distance equals 111.2 times 40. And if you just pop that in the calculator, it'll come out to 4,448 kilometers. Okay. So now let's have a look at this example here. So once again, I'm going to draw a diagram. Just get my Earth going. Put in the equator. Put in my prime meridian, 0 degrees. Now, so firstly this time I've got 25 degrees north. So let's just say it's there. And then 40 degrees west. So this time I'm to the left of the prime meridian. And then the intersection between those two is where that point is. So notice what stayed the same this time. We're both on 40 degrees west. So they're on the same longitude. But our second place is at 18 degrees south. So that's going to be below the equator. Just mark that in. So here's this place. So once again, we can see we're traveling in a north-south direction. So we're just using our simple formula. Distance equals 111.2 times the angular distance. Just abbreviate that there for now. So firstly, we'll work out the angular distance. So that really is our change in latitude in this situation, we could call it. So notice if we've got one of our locations is north and one is south, we're crossing the equator. So this time we have to add those two angles together. So 25 degrees plus 18 degrees, and that will be 43 degrees. And then that just feeds into our formula. So the distance is simply 111.2 times 43, which calculates to 4,781.6 kilometers. Okay, so that's quite straightforward. As long as you do your diagram and you can see, it's easier to visualize what you're doing. Now let's have a look at a couple of examples where we're traveling this time along a latitude. So this time, have a look, notice that it's the 70 degrees north is the same this time. So that means they're both on the same latitude. So I'll draw the diagram, put in the equator, and put in the prime meridian. So we're on 70 degrees north, so I'll just pop it up above the equator. And then now the first place is 120 degrees east. So we're to the right of the prime meridian. And then we've got 150 degrees east. So that's further east. So that's to the right of the previous one. Okay, and here's the two places, our two locations. This time we can see now that we're traveling on a latitude. So that means we have to use the other formula from the formula sheet that says distance is equal to 111.2 times cos theta times angular distance. So what we want to remember is that now our theta is important, and that we're getting from the latitude that we're traveling along. Okay, now we still need to calculate the angular distance, and we're doing that in a similar way to what we did when we were traveling on a longitude. So notice both of our locations are east. So if they're both east, we're going to subtract. So 150 degrees minus 120 degrees is 30 degrees. So if they're both the same, if they're both east or both west, we would subtract. Now I can put that into the formula. So we've got 111.2 times cos cos 70. Just fix that up, because we're looking at which latitude we're going along, and then we're multiplying by our angular distance of 30. Now if you just pop that in the calculator, that comes out to 1140.98 kilometers. Okay, next example, once again we've got the same latitude. This time it's 32 degrees south. So we'll draw our diagram. Pop in the equator, pop in prime meridian. Right, so our first location, 32 degrees south, so this time we're below the equator. And 125 degrees east, so I'm to the right of the prime meridian. Now our second location is on the same latitude, 32 degrees south, but this time we're 95 degrees west. So I'm to the left of the prime meridian. So once again, you can see that we're traveling on a latitude. So we're using that formula, same as last time. Distance equals 111.2 times cos theta times angular distance. So where we're noting that our theta comes from the latitude that we're traveling along. Now first we need to do the angular distance. Now notice this time we have crossed the prime meridian. We've gone from east to west. Now I just notice I put an E up here instead of a W for west. So just fix that up. Okay, so the angular distance, we're traveling from east to west, so we have to add those. So we've got 95 plus 125 is equal to 220 degrees. Now remember that if we were to travel all the way around the Earth, that would be an angular distance of 360 degrees. So when we've gone more than 180 degrees, we've actually gone like more than halfway round. So it would be a shorter distance to go the other side of the Earth. So when your angular distance comes up over 180 degrees, what we're going to do is go shortest angular distance. And this only happens when you're traveling on a latitude, not with the other ones on a longitude. So we're just going to go 360 minus the 220 degrees, which is 140 degrees. And now that is the angular distance that we're going to go put into our formula. So we'll say distance, or we might want to clarify that it's the shortest distance, is equal to 111.2 times cos of 32 times our shortest angular distance of 140. Now, if we pop that in the calculator, we would get 13,202.4 kilometers. So there you go. That's a few different variations on calculating distance on the Earth. Hopefully that's been helpful.